Welcome to Omega Open Course. In this video, we are going to discuss about the angle of friction and its application in solving numericals. Angle of friction is very powerful tool in solving numerical problems. It saves a lot of time in calculation and frees you from the need of drawing free body diagrams and writing equations almost entirely. Unfortunately, no book gives it the importance it deserves. You might already be familiar with angle of friction. Suppose a block is kept at rest on a rough horizontal surface and an external force F is being applied to move it. Furthermore, let us assume that the block is not moving. The surface applies two forces on the block. The one perpendicular to the surface is what we call normal and another along the surface which we call friction. The resultant of these two forces is called contact force. The angle this force makes with the normal is called angle of friction. In case the block is not moving, that is the frictional force is static, then this angle is a variable quantity. If we increase the external force, the friction force also increases and so does the angle of friction. Similarly, if external force is reduced, the friction also reduces, reducing the angle of friction. If we keep on increasing the external force, the friction keeps on increasing. But the static friction has a maximum limit to it, after which the blocks start sliding. When the block is on the verge of slipping, the force of friction is equal to mu times normal. If the angle of friction at this instant is phi, then tan phi is given by mu n divided by n, that is mu, which implies phi is equal to tan inverse mu. Thus, tan inverse mu is the maximum value of angle of friction. If external force is increased further, the block starts moving, but the value of friction force remains mu times n and thus the angle of friction remains fixed at tan inverse mu. Now that you have understood the basics of angle of friction, let us see how it is used in problem solving. A large number of questions on friction usually revolve around the limiting value of friction, that is when the motion is impending. As we have seen, in that case the angle of friction is tan inverse mu. Now the forces acting on the block can be divided into two parts. The first part is contact force, which is of course the resultant of normal and the friction, and resultant of rest of the forces which try to move the block from its position. In the limiting case, when the block is just about to move, the net force on it is still zero, and hence these two forces must cancel each other out. This means contact force must be equal in magnitude and opposite in direction to the resultant of rest of the forces. Thus, the angle that the resultant of rest of the forces makes with the normal is equal to the angle of friction, and when this angle becomes equal to or greater than tan inverse mu, the block starts sliding. So whenever we have to deal with the limiting value of friction, we can simply take forces other than contact force and find its direction with the normal. In limiting case, the resultant has to make angle tan inverse mu with the normal. Thus we can find the required value just using geometry and trigonometry without balancing forces or writing multiple equations. This tool can be used in myriads of ways in different situations and conditions. It just depends on your problem solving skills. Given on the screen are just a few questions from H.C. Verma which we have solved or we will be solving using angle of friction. Watch these videos to get proper understanding of how angle of friction is used in problem solving. In case you want further clarification or elaboration at any point, feel free to post it in comment section. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching.